Hello everyone. Welcome to the solution of LeetCode problem 617 named Merge Two Binary Trees. In this problem, we are given two binary trees, root 1 and root 2. Now, imagine that when you put one of them to cover other, some nodes of the two trees are overlapped, while the other are not. And you need to merge the two trees into a new binary tree. The merge rule is that if two nodes overlap, then some node values up as the new value to the merge node. That means, suppose the value 1 and 2 overlap. So here, the new node value will be the 3, which is 1 plus 2 is equal to 3. Otherwise, the not null node will be used as the node of the new tree. After that, we have to return the merge tree. Now, the merging process must start from the root nodes from both of the trees. Now, let's consider the first example. The first tree contains the root 1, which has two children, 3 and 2. 3 also has one children, which is 5. Now, 2 has two children, 1 and 3. 1 has one children, 4. And 3 has right children, which is 7. Now, if we merge them, 1 plus 2 will become 3. 3 plus 1 will become 4 here. 2 plus 3 will become 5. And now this node 3 has a left node which is 5, but this node 1 does not have any of the left node. So we will add 5 here. Now again, this node 3 does not have any of the right node, but this node 1 does have a right node. So it will be added here 4. Similarly, this right children 7 will be added to the node 5 here. So this is how the basic merge works. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example, which is described in the example 1. Now here, we have to use the DFS function to solve this problem. Now let's see how can we solve it. We will start the DFS function into the root of the both of the tree. Now here, this root value is 1 and this root value is 2. So we have to make the new root value, which is 3, which is the summation of both of them. Now the DFS call will be in the left subtree and in the left subtree for 1 and 2. Now again, it has the node 3 and 1. So this left will be 3 plus 1, which is 4. Now from 3, the call will be again its left subtree, and from 1, the call will be again its left subtree. But wait, 1 does not have any of the left subtree, but 3 have. So we have to add the value of the 5 here. That means if the left of 1 is null, we have to return this 5. Or suppose the first node name is P, or the first tree name is P and the second tree name is Q. That means if the left value of the Q is absent, we have to return the left value of the P. So it is 5 added here. Now from 3, we will get back to the node 3. We will get back to the node 1. Now from 3, we will call the DFS into the right subtree, and from 1, we will call the DFS into the right subtree. Now here, we have seen that 3 does not have any of the right children, but 1 have. So we have to return the right children of 1, which is 4. That means if the P does not have any of the right children, but Q has, we have to return the node presented in the queue. Now we will get back to the root 1, we will get back to the root 3, from 3 we will get back to the root 1, from 1 we will get back to the root 2. Now from 2 we will get back to the 3, and from 1 we will get back to the 2. So here we have to add both of the value 3 and 2, and it will become 5. Now we have to go to the left part of the 2, but it does not have any of the left part. And from 3 we have to go to the left part, so it does not have any of the left part. So we don't have to append anything here into the left part of the 5. Now from 2 we will go to the right part, but it does not have any of the right children. From 3 we will go to the right part, which is 7. So we have to add 7 here. Now from 7 we will get back to the node 3, and from this we will get back to the node 2, and from node 3 we will get back to the root 2, and from node 2 we will get back to the root 1. Now from 1 we will return, and from 2 we will return. Now we can see that this tree is the merged version of these two binary trees. And this is how basically the algorithm works. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named merge trees, which has two trees P and Q as a parameter. And here, if the P is null, we have to return Q. And if the Q is null, we have to return P. Now, if both of the node P and Q exist, we have to add the Q value to the P of value. And now recursively call the merge tree function with the left part of the first tree and with the left part of the second tree, and assign them to the left subtree of the first tree P. Again, we have to recursively call it in the right subtree. Finally, we have to return the tree P as the output because we have manipulated the root P. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.